Where's Tony? Huh?
So we only have a short agenda today. So we are just wait for a couple more minutes before we get started.
Hi everyone, welcome to IETF 113 Reef Working Group meeting. It's going to be a reasonably short meeting. We've got two presentations. Next slide, please. By now you should know not well describe how your input and participation in IETF is treated. Please read it if you haven't before. Meeting tips. You could join on site. Please do so we know you've been present and your name will show up on blue sheets. And please keep your audio and video off unless you're presenting. So those are the links to agenda and other information. And agenda for today, we are going to quickly update you what's going on, and then we have two presentations from Jordan on Leaf AutoFR and AutoVPN. So where we are within working group, the base spec has been updated a couple of times. Thanks, Alvaro, for reviewing and software with Tony. So it's pending new review. Applicability statements pending. Alvaro's reviews. Young model working group is in process. The data model is in good shape. So we expect to finish after IETF. Same goes for the KV registry. Work on AutoVPN is in progress. Now there's implementation. Segment routing is in process. Multicast, we are not going to update it. I mean, we are going to update it, but not to work on it for sometime in the future. When there's more demand, probably we will start updating it again with more details. And Jordan.
Get situated, or if you guys want to share. Yeah, that works. Okay. Let me get situated. Okay. All right. So first off, thanks, chairs. Thanks for the time today. So the deck being proposed today is we're taking advantage of Rift's architecture to automatically build flood reflection topologies, but I want to spend a few minutes and just give some kind of quick context about the problem we're actually trying to solve with flood reflection. I think it helps make everything that we're doing with Rift make a bit more sense. Next slide, please. So let's define the problem. So we all know that flat single area IGPs come with some pitfalls. So flooding in that every node needs to know everything, state in that every node needs to maintain, and convergence in that every node needs to compute. So this gets even worse as the network is scaled. But these sorts of deployments are, pretty desirable. SR is a good example of that. Next slide, please. So let's visualize it a little bit more, right? So this is just a relatively small, like flat level 2 ISIS network, single flooding domain. As this network grows and grows, scale starts to become a concern. Going over what we just said, right? If there's lots of state, each node has to maintain it all, both in terms of adjacencies and link state database. There's more and more flooding. It has to distribute more LSPDUs to all the nodes. And, lastly, slower convergence. That link state information is then computed against SPF, and this just compounds as it grows. Next slide, please. So what's the solution? ISIS flood reflection. It's based on existing work in LSR. I'd encourage you to check out the draft if you're interested. It's pretty short, pretty easy. But in short, it basically works a little bit like BGP route reflection. We choose a cluster ID, and we designate one or more flood reflectors. We designate one or more flood reflector clients, and we get some pretty desirable properties. Next slide. So basically, we take the previously flat level 2 network and we split into multiple flooding domains. So we have L1, L2 nodes that are establishing flood reflector adjacencies inside level 2, and the flood reflectors themselves will sit at the top, and the flood reflector clients will sit down at the bottom. Leaves that are also split into L1, L2 nodes. So basically, we can leak L2 routes from the leaves, tier 1 into level 1. There are other methods as well, like tunnel-based deployments that are detailed a little bit more in the LSR draft. But the point here is that L1 and L2 converge independently of one another, thus solving a lot of the problems. Next slide, please. So just kind of a quick before and after, just for those who are visually inclined. We can kind of see the difference there with those dotted lines on the right being the flood reflector adjacencies between the nodes participating in level 2. Next slide, please. And so a little bit of, metrics against scale. So considering our topology shown here, without flood reflection, it's roughly 15 adjacencies. But with flood reflection, we reduce it down to 8. And obviously with that, we have other components as well. Next slide, please. And, the other factors, right? Less links and less adjacencies means we get less, link state PDUs. Less link state PDUs means less flooding. And both of those mean less SPF computation overall. So ultimately, it's a pretty clear improvement scale-wise with flood reflection. But next slide. What's that got to do with Rift? So flood reflection, like Rift, is pretty well suited for plot topologies. So basically, for those familiar with auto EVPN, it's pretty similar context, but for those that aren't, Rift will build the underlay, quote unquote, and then we'll use auto FR to actually build the flood reflection topologies on top of that. So we do that by automatically deriving variables important to flood reflection. Like I said, the cluster ID and loopback address. Actually, next slide, please. Sorry. Yeah, so we have flood reflector, the cluster ID, loopback address, all the information relevant to ISIS, and they can be computed. It's distributed computation. Each node can figure it out on its own. And we can build those topologies pretty simply. Next slide, please. So this is just one example of what some of that derivation looks like. There are other functions in the draft that are outlined pretty clearly. And yeah, I just kind of encourage you to take a look at it. I just want to give you a rough look. And also too, there are AutoFR analytics. So we use, look like the share dropped. Give it a sec here. We're almost done anyway. It's slide 12. Yeah, so we have AutoFR analytics. So Jeff mentioned that key value registry that's going through working group last call. Basically, we use those key value ties, the link state information and RIF to distribute operational information about AutoFR. So rather than having to look in at every node in the network, you can just go look at the top of fabric nodes that would be participating as flood reflectors, and you can see, you know, a rough general state of everything. You know, helps in things like troubleshooting. And next slide. That's it. So what's next right now? You know, first pass. So I'm interested in feedback, co-authorship, anything, and some more, you know, operational considerations and examples as well. And yeah, that's it. Any questions?
So I actually have a question. Is it that this applies to cross networks, but in situations where an operator choose not to run Rift, but run ISIS instead, but still we can use the Rift, some Rift procedure to help the flood reduction in ISIS?
I might let Tony take it if he doesn't mind with the implementation side. I haven't thought through that particular component.
I was on the chat. What was the question, Jeffrey?
So I just want to confirm my understanding that the scenario here is that you have a class network, but you are not running the Rift protocol for the link state or route calculation. You're running ISIS, but you're using some Rift's underlying protocol procedures to help with the ISIS flood reduction.
Yes and no. Can we flip back to the topology picture? Yeah. All right. So now, if you take it towards the ISIS direction completely, then yes, Rift is kind of only ZTP if you want. Okay. And then it configures L1 and L2 ISIS, and everything is ISIS. And at this point in time, Rift is kind of just hanging there for you know, the cloud topology and figuring out who has which role on the topology. But you can just as well not configure L1 and use Rift to forward packets. Right. So you also have this option. Depending which flavor you prefer, there's pluses and minuses to both. That kind of goes deep. Flood reflector has two flavors. You can either build a full mesh of tunnels between the L1s, the leaves, or you can run it without tunnels, where you're basically leaking from L2 into L1. You can leak from L2 into Rift just fine, if your implementation supports that, and then Rift does the stuff. If you run tunnels, it depends how you configure it. If you configure the tunnels somehow manually between the leaves, you can run Rift, but the flood reflector in L1 is also flooding in ISIS the roles and the tunnel endpoint. So that allows you to basically configure the mesh of tunnels fully automatically. So it's kind of, you know, your choice. You could run Rift for L1, but the way I think we wrote the draft and the more natural choice is to configure both L1 and L2 and then get all your stuff. Well, No, actually, you need L1 if you really want the L1 tunnel discovery. And I'm not talking about the tunnels, the flood reflector tunnels, the little dotted lines here. I'm talking really about full mesh between the leaves, which is a flavor of flood reflector used to forwarding. Because the leaf stuff, the flood reflection tunnels, the dotted tunnels, which are only used for flooding, this stuff you already have with Rift. You can automatically configure that.
Tony, so
I
trying
hope
to
I
summarize
didn't add.
what you just said, we are using Rift as GTP technology for ISS here, right?
Right, so Bruno asks again, what is the scope here? Well, so Bruno, the scope is here that Rift is used as ZTP to bring up a claw and then configure, give you everything to configure ISIS flood reflection automatically on top of that. But there is a flavor that Rift could be also the L1 protocol, and then you don't need ISIS L1.
So I would think it would require charter extensions. Alvar? Yeah, so using Rift as a non-routing protocol, but something else is not in scope today. And I'm looking at Alvar and his comments on this.
Hi, Alvaro Retana, Routing AD. I wasn't exactly going to say that, but you're right. What I was going to say, or what I was going to ask, is whether you had talked about this in LSR. At least you should, right? Because there's a close relationship between this work and the flood reflection draft there. And also the other observation that I was going to make is that the flood reflection draft seems to be experimental in LSR. So if and as this goes forward, we would want to keep an eye on that as well.
Right. So I think auto EVPN has been shown in IDR. It's a good suggestion to get. Let me put it on my action item list. So it's a good suggestion to actually show that in LSR. Yes, the flood reflection experimental. I mean, I don't know which track this draft is being suggested for. I mean, I'm kind of okay with anything informational, experimental. So, we'd like to have this thing at least experimental because people can interrupt that stuff. This is beyond just, that's what you can do. Everybody has to derive these values based on the Rift topology the same way for the whole thing to work. With kind of needs interoperability. So my action item is to actually somehow poke the LSR and present it. Yeah, we'll do that. Thanks.
Alvar, with regards to charter, do we need to extend charter explicitly to allow work on this kind of scenarios?
Yes. So yes, I agree with you that I mean, right now we're chartered to do a routing protocol. Even if the same protocol is going to be used for discovery, auto configuration, whatever we want to call this, yeah, we probably need to recharter.
And of the charters, deputy and LSR, I'm canceling all the drafts there, and we'll be talking about that. Any questions here from anyone? So auto VPN drafts. No, slides are coming. Jordan?
Well, none of the stuff comes up as basically, we bored and we have nothing left to do. This is actually customer poking us, like asking, could you do something like that? Which the first answer was no. And then after we thought about it more, we figured out actually, yes, it works.
Jordan?
Yep. Sorry. Okay. I was just making sure no one else had comments there. One sec. Okay. Pretty brief update with this one. If we could just jump to the next slide for me. Once I can find my deck. Okay. Okay. So just, I'm sorry, looking at the wrong side of it. Bear with me. Okay, sorry about that. Okay, just a couple of updates on Auto EVPN. Nothing too big this time. Next slide, please. Oh no, that one's good. I'm sorry. Back up one. Thanks. Okay, so the main changes here are improved, so to speak, variable derivation for some of the numbering, things like IRB, VLAN, and the EVI values. Big thanks to Olivier for that, and some through schema changes, just to move stuff around and make things a little bit more simple with regard to advertising a node's capability and some of the specific variables within the fabric inside RIF rather than just inside Auto EVPN exclusively. Next slide. So just to give a rough example, so previously some of the results would look like this. The main thing to point out would be, like the VLAN ID and the IRB are not identical values. A couple, works perfectly well, but some of the operators preferred that the IRB and the VLAN ID matched to keep things kind of, simple, aligned with their existing deployment practices. If we jump to the next slide, basically improved it. Tony did some work with the hash computation or the computation functions and was basically able to get things to line up without, a scale reduction or anything like that. So makes operators happy and makes, verification troubleshooting easier, honestly, in my opinion, too. Next slide. Just there are a couple other things, but these are the important ones. Basically, the main Rift thrift schemas carry the fabric ID components, the default fabric ID and undefined as well. And then the encoding piece, the node capabilities and node flags now carry Auto EVPN and whether that node supports it or not, the node flags will carry, if there's a data center interconnect functionality required for Auto EVPN. And last slide. That's really it. But what's next is, again, co-authorship comments are welcome. We're still working toward more multi-plane and data center interconnect examples, and then some operational stuff that fell off the radar a little bit this time. But any questions regard to that? Okay, that's all I had.
Okay. One more follow up on that segment routing work. So we did not get a chance to update the draft, but it was pretty complete and stable from the author's point of view already. So after IETF this session, we are going to issue a adoption call.
I also had a discussion with Spring chairs after, and if the document is adopted, we'll probably also do short presentation in Spring.
So with that, I think we finished our agenda today. Alvaro, do you have anything to add? No? Okay. So we're done today. Thank you.
An action point to the chairs to update charter by next IETF. I mean, we are taking the action point.
Yeah, let's please start discussion of the charter. It would be ideal if by the time I send the RIF document and the applicability one to the ISG telechat, at that same time, because we finished the work, we can discuss the new charter.
Sorry. So you want to send it before we update the chart. So we wait for you to send it to ISG first, correct?
Right, correct.
Okay.
Correct. Otherwise, the ISG is going to say yes, but you haven't finished the work.
Okay.
Right.
Then we are gated by Alvaro. Thanks, everyone, and really hope to see you face to face, even Tony in Philadelphia.
Okay. Bye.
Bye, everyone. calculus.
I think you have a, well, let me confirm. Yeah, but when